Okay guys, so now we're going to talk about adding vectors mathematically. Now what this means is this, okay, so if we have two vectors, okay, if we have two vectors, one of which does something like that and the other one does something like that, okay, finding this resultant, right, finding that resultant with two vectors that are diagonal. Well, we have a few steps to do that, okay. Now before we get started, I do want you guys to write down that steps to have it in your notes. So you see these 6 steps here, go ahead and pause the video and write down those 6 steps. Okay, now that you guys have those down, let's go ahead and see how to do this. So this first step was to break these two vectors up into any of their components. Right? So you have 3 newtons. Now, kind of figuring out both of these components, you have 3 newtons. West is your baseline, and it goes north of that 40 degrees. Okay. So that's the first one. The second one, you have this component here, the south component there, and you're going to have 5.2 newtons. West is your baseline, you're going to move 13 degrees. So 13 degrees south of that baseline. Okay, so let's break these down into components now that they're in this manner. Okay, so first one, we're going to try to find this adjacent side and this opposite side. So remember, we're going to use to find those lengths of the adjacent and opposite sides. Okay, so in order to find adjacent side, you're going to use cosine. So remember, cosine of theta is equal to adjacent over hypotenuse. Now the hypotenuse here is 3 newtons. Okay, so cosine of 40 degrees is going to equal adjacent divided by 3 newtons. Okay, so from here, cosine of 40 degrees, that is just a number, if you remember. So cosine of 40 degrees, when you plug that into your calculator, you're going to get 0.76 as a number. That's going to equal your adjacent divided by 3. So you multiply 3 to both sides, multiply 3 to both sides, to give you the answer for the adjacent side. So you have 2.29 newtons is your adjacent side. And that is going to be moving, so the direction of that is essentially west. So I'm just going to draw an arrow, but it's going to be represented as west. Okay, so now that was the x component. We just found the x component of the first vector. Okay, now what we have to do now is we have to find the y component. Now to find the y component, you're going to use sine. So same thing, sine of theta is equal to, now this one's a little different, it's opposite over hypotenuse, opposite over hypotenuse, so sine of 40 degrees is going to equal opposite over 3. So the sine of 40 degrees, when you plug that into your calculator, you are going to get 0.642. And then you're going to, that's opposite divided by 3, multiply both sides by 3, multiply both sides by 3. You're going to get the opposite side is going to equal 1.92 newtons. Okay, so this is 1.92 newtons, and this is moving up. So that would be considered north. Okay, so just breaking that down. Okay, now let's move on into the next one. Let's do the same thing for the next one. I'm going to speed up the algebra on the next one. Okay, so we have first one. We know that this is our adjacent side. This is our opposite side. We know that we're going to need cosine. Now to speed things up, this is 5.2, right? So 5.2 cosine of 13 degrees will give you the answer, essentially, A, right? So if you put that into your calculator, 5.2 cosine of 13 degrees is 5.06. Now, the reason why I can do this, just think about using algebra, okay? 5.2 is going to be on the bottom of this fraction, if you look over here, right? 5.2 would be the bottom of the fraction. You just need to move that over and then multiply it by 13 cosine, or cosine 13 to get you the answer. So it's just bringing it together, making it a little bit faster. So you have 5.6, and that is going to equal your x component, and it's moving to the left. It's moving west. Okay, so same thing. 5.2 sine of 13. That's going to equal this length here. Okay, and 5.2. When you plug that into your calculator, you will get 1.16 or 169 newtons, and that's going straight south. Okay, so that's step one. The second step is adding, so if you remember from your notes, so add all the x components and then add all the y components. So here, this is my x components, so this and this are my x components. Now notice one thing, they're both going in the same direction. Both of them are going west. So if they're both going in the same direction, you add them and then you denotate it as going west. So here I have 2.29 newtons going west plus, so both of these are going west, plus 5.06 newtons also going west. Okay, so if you add those two together, 2.29 plus 5.06, you are going to get 7.35 newtons going west. Okay, now from there, now let's add whatever's going north and south. So here I have 1.92 newtons going north, and then here I have 1.69 newtons, but they're going south. So what we're going to do is subtract it. Okay, so we have 1.92 newtons, and that's going north. Okay, so it's going north. We're going to subtract it by 1.169 newtons because that is going south. Now the answer that we get for that, 1.92 minus 1.169, the answer you get for that is 0.751 newtons. And the resultant is going north, right? So north is a little bigger than south, so it should end up going north. Okay, so from here, now you can do a couple of things. Okay, so now we just did 1 and 2. We just did 2 and 3. Now let's do 4. Okay, let's find the magnitude. So to find the magnitude, I'm going to draw this as well. Okay, so we have 7.35, so 7.35 newtons going west, 0.75 newtons going. What we are asking ourselves now is, what is the magnitude of the hypotenuse, essentially, right, or of our resulting vector? So the way to calculate that is simple. Pythagorean theorem. Here's your two legs. There's your right angle. You can use Pythagorean theorem. So 7.35 squared plus 0.75 squared, that is going to equal c squared. So the square root of 7.35 squared plus 0.75 squared will be the magnitude of that specific. So that's going to be the hypotenuse, right? So what I got 7.38 newtons is the magnitude. Okay, now we have to find the direction. Okay, so this is the last step. Direction to find this angle here. So one thing is tangent. Okay, tangent looks at, so the tangent of theta looks at opposite over adjacent. Now to find that angle, you would do tan inverse of that ratio, opposite divided by the adjacent, is going to give you theta. So let's find what theta is. Let's find this angle here. So in order to find that, you have your opposite, which is 0.75 divided by 7.35, and then take tan inverse of that number. So 0.75 divided by 7.35, I got 0.102. Okay, now take the tan inverse of that, so second tan. And my angle is 5.82 degrees. Okay, so and that's essentially from here. Now you kind of have to write it out. So this is your magnitude. That's degrees. Okay, so writing this out, you have a resulting vector of 7.38 newtons, and then you have your degree sign. So your baseline is west, 5.82 degrees north. If you guys have any questions, just send me an email. Both the 6 problems from practice 6 and the 6 problems from practice 7 are due tomorrow. So have a good day.